work, power and energy. First, we will discuss the topics work. By the end of this topic, students will be able to explain the definition of work, types of work, write down the unit and dimension of work, determine the amount of work by applying formula of work. By work, we mean to do something in our everyday life, like sitting on a chair or lying down on a bed and sleeping. Here you can see a person is sitting on a stool and a person is lying down on a bed and have a sleep. But in science, doing anything is not work. In science, the term work represents a definite concept. In science, work is done when displacement is associated with force. That means if we apply force on an object, the object should be displaced from its position, then it is considered to be work. If a force acts on a body and causes its displacement, only then work is said to be done. Here you can see, in first case, a person is applying force on a box and displacing it. And in second picture, the person is applying force, but the box didn't displace from its position. So in science, the first case is considered as work, but the second one is not to be considered as work. So how can we define work? So here you can, the definition of work. Work is measured by the product of applied force on a body and its displacement along the direction of force. Here, notice that displacement along the direction of force. That means when we apply a force on a body, the body should displace at the direction, in the direction of force. Work equal to force into displacement. If a force is expressed by F is applied on a body and the body travels a distance is expressed as S along the direction of force, then the work done is expressed by W will be, we know work is the product of force and displacement. That means work equal to force into displacement. That means W equal to F into S. That means W equal to Fs. The unit of work is joule. Joule is the name of scientist. So we will use only capital J. Work has no direction. It is a scalar quantity. Now, work can be divided into two groups. Work done by force, that is called positive work, and work done against force, that is called negative work. If the displacement takes place along the direction of force, then work done is said to be work done by force. That means if we apply force and the displacement occur in the same direction, then this work is called positive work or work done by force. If the displacement of a body takes place opposite to the direction of force, then work done is called work done against force. That means if we apply force in a direction but the displacement occur in the opposite direction, the force is applying in a direction and the displacement occurring in the opposite direction. This type of work is called work done against force. That means negative work. You can see a book, lifting a book. The weight of book acts in the downward direction. When we lift up the book, the displacement occurs in the upward direction. That means force acts in downward and the displacement occurring in upward. That means opposite direction. So lifting up a book is negative work. When we drop down the book, the weight of the book acts in downward direction and the displacement also occur in downward direction. So force and displacement occurring in same direction. So dropping down a book is positive work. Now, unit of work. The unit of work is obtained by multiplying the unit of force with unit of displacement. We know work equal to force into displacement. The unit of force is Newton and unit of displacement is meter. That means Newton into meter. N into M, here we are using capital N. Why? And the meter is small m. Why we use capital N? Because Newton is a name of scientist. When there is a name of scientist, the unit will be in capital letter. That means Newton into meter, that means Newton meter, Nm, that means joule. Joule is the name of scientist, so it will also be a capital letter G. What is 1 joule? We know the work equal to force into displacement. That means the result should be 1. That means if we multiply force and displacement, its result should be 1. That means 1 Newton into 1 meter equal to 1 joule. So we can define it like if an object has 1 meter displacement towards force, from applying 1 Newton force on it, then the amount of work is 1 joule. Here you notice that 1 Newton force is applied on the body and the displacement also occurred 1 Newton. If I ask you what is 40 joule, then how will you answer? We know the product of force and displacement should be 40. So it can be 1 Newton into 40 meter, or 2 Newton into 20 meter, or 4 Newton into 10 meter, 40 Newton into 1 meter, or 10 Newton into 4 meter. That means the product should be 40. Every term will be right answer, but we prefer the round figure. Now, how can I describe this? If an object has 1 meter displacement towards force, from applying 40 Newton force on it, then the amount of work done is 40 joule. Now, dimension of work. Dimension of work will be dimension of force into dimension of displacement. We know work equal to force into displacement. Force equal to mass into acceleration. So, it will be mass into acceleration into displacement. Acceleration equal to change of velocity by time. Then this will term mass into change of velocity by time into displacement. Again, velocity equal displacement by time. Then it will term mass into displacement by time square into displacement. The dimension of mass is m, displacement is L, and time is t. Then from mass it will come m, displacement L, time square means t square, displacement L. So the dimension become W equal m L square t inverse 2. Now an important question. Work is a derived quantity, explain. What is derived quantity? The quantity which depends on 2 or more fundamental quantities is called derived quantity. Work is also a derived quantity. There are 7 fundamental quantities. In chapter 1, you have studied and learned that we have 7 fundamental quantities. The quantity which depend 2 or more fundamental quantities is called derived quantity. Work is measured by the product of applied force on a body and its displacement along the direction of force. Work equal to force into displacement, that means mass into acceleration into displacement. Acceleration equal to change of velocity by time, that means mass into change of velocity by time into displacement. That means mass into displacement by time square into displacement. Here we see that work quantity depends on fundamental quantity, mass, displacement and time. Mass, displacement and time, these 3 are fundamental quantity. As work depends on 3 fundamental quantities, that means work is a derived quantity. Another question like this is the unit of work is derived quantity. Similar to the previous question, the unit which depends on 2 or more fundamental unit is called derived unit. The unit of work is also a derived unit because it depends on 2 or more fundamental units. Work is measured by the product of applied force on a body and its displacement along the direction of force. You have to answer it like this. We have studied it earlier. Now you can see that the unit of mass is kg, displacement is meter, time is second, displacement is meter. That means it become kg meter square by second square. That means the unit of work depends on fundamental unit kilogram meter second. Therefore, the unit of work is a direct unit. Now, we can solve mathematical problem here. If 5 Newton force is applied to a body and it displaced by 50 meter from its position, then determine the amount of work done. In the question, there is force 5 Newton. Given force F equal 5 Newton and there is a displacement 50 meter. We know W equal to Fs. So force into displacement, that means 250 joule. Another problem, a man of mass 70 kg climbs on a mountain of height 200 meter. How much work will he do? Here you can see that there is no force. So, given mass of man M equal to 70 kg. As there is no applied force, the weight of the man is the acting force on him. So, force F equal to weight of the man, that is weight equal to mg. We have learned it in class 8. Weight W equal to mg, weight is also a force. So, force equal to weight of man, that is mg, mass into gravitational acceleration. We have a fixed value of gravitational acceleration 9.8. We mathematically use this term fixed 9.8. But it can be vary in different places of world, but mathematically we use the fixed value of gravitational acceleration 9.8 meter per second square. So, the weight of the man is 70 kg into 9.8 meter second inverse 2, that means 686 Newton. Displacement, here he climbs the mountain of height 200 meters. So, he displaces 200 meter. So, here displacement is equal to 200 meter. The formula W equal to Fs, that means 686 Newton into 200 Newton. In calculator you will calculate this value 1.372 into 10 to the power 5 joule. Here is another mathematical problem. An empty lift has a weight of 7200 Newton and it's powered by an electric motor. The lift takes a person up 25 meters in 40 seconds. The person weight is 800 Newton. Calculate the work done by the lift's motor. Here you can see that we have time. In previous mathematical problem we do not have any time, but in this mathematical problem we have mentioned time. But nothing to worry, everything in the question will not be used. So, the total weight, the weight of lift is 7200 Newton and the weight of the person is 800 Newton. That means if we plus this sum of these two weight, we will get 8000 Newton. Displacement is equal to 25 meter and work done will be W equal to Fs, that means 8000 into 25, that means 22,000,000 joule. Now, we have come in at the last topic, that means homework. What is work? we have discussed it on our lesson. What do you mean by work done? 25 joule. Determine unit and dimension of work. Your mass is 50 kg. You have climbed up a 10-story building. Height of each floor is 3 meters. How much work have you done? Now, there is a step. Shahid is waiting for train with his bag. When the train arrives, Shahid puts up his bag and gets on the train. The train starts to move just in time. Now explain the types of work from the step. Puts up his bag, putting up, lifting up, that means negative work. Starts to move. Train always starts in straight line. That means starts to move is a positive work. So thank you for your kind attention. Thank you for the class.